All right, following up from the prior video and similar to what we did in class, the next example from a run sample z-test, different data set, still made up, but a couple different parts to it just to walk you through the mindset of it. So professor is interested in if their current students scored better, or with that, the key part again, greater, so we want to come back to that. Then all students who have taken the same stats course, given the type of course, the professor wants to be first confident in their findings and use 1%, then given the course wants to then change it to see what happens if we use 5%. Again, we know it's directional. We have two different probability values of 1 and 5%. So with that, we're going to have two critical values, same obtained. And what can we conclude? With that, since we have 1% first, the key part is let's do that. And if it's our attains greater than our critical, we're already in good shape and don't really have to do much with our critical value at 5%. So again, if we start off, we first want to have our null hypothesis here. So our H0. Again, this is true equality, so there would be no difference. They would be the same. So it'll look as the current class mean score is the same as all student. That's our population, just all students. Oh, this should be the U there. I'll just put mean score. Good to go there. And if we switch to our research hypothesis, the key part here is we already see that there is directionality. So we already know that part. So we have that part taken care of. So when we write up our research hypothesis, it needs to reflect that directionality to it. So our research hypothesis is the current class mean score is greater than all student score average. So I'm just saying it a bit different, but getting at the same thing. So we now have our null hypothesis, we have our research hypothesis, we know it's directional. Given that our first part is for the critical value, so we know it's directional. And since here we have just the 1%, since it is directional, we don't have to divide it and do the non-directional side. So we're truly, in terms of the chart, our critical value, we want to see if our value is greater than that. If it is less than, that's when we fail to reject our null hypothesis. If it's greater than, that's when we can reject it. So we're trying to find our critical value that we need to get beyond to reject or fail to reject our null hypothesis. So with that, we're going to look up a value then as close to 0.990 as we can. So again, if we move this decimal place over from our prior ones, this will give us our 99%. So we're trying to find as close to 99.0 as we can find. Again, going to open our Z table. And if I scroll along, we have 2.3. You can see again, we're kind of close to 0.02 or 0.03. So I'm going to go 2.33. So that gives us a nice value there. I'm going to come back to the whiteboard. So our critical value is 2.33. So in terms of this diagram here, we would need a value greater than 2.33 to reject our null hypothesis. So we now have that taken care of. I'm just going to move this over a little bit so I have a bit more room on the side and calculate our Z. So again, we're solving for our Z here. So in the numerator, we have our mean of our sample of 94.3 minus our population mean of 89. Got too close to that, so let me move it a little. 3 over our standard error of the mean, which is our population standard deviation of 10.5, over our sample size, 54, and the square root of that. So again, I'm going to solve just the top part first. So I'm going to pull up my calculator that's off screen. 94.3 minus 89.3, which gives us, in the top part, we have 5 then over 10.5. And now if I take the square root of 54, get 7.35 with rounding. So I continue to solve downward. So 5 divided by, we would take our 10.5, divide by 7.35, gives us 1.43 rounding. Again, if there's a couple tenths or hundredths off, it's probably when we're rounding. There's a bit difference between what you do and I do. But with that, now we can take 5 divided by 1.43, which gives us a value of 3.49. If you round, it would be 3.5. But here's where we can now, I'll draw another table for it or a diagram. We know our critical value is 2.3. And it doesn't like when I get too close to anything. And then we have an obtained value of 3.49. So I'm going to just put over here, obtained is 3.49. So we already know, since it's past our critical value, so it's gone beyond, that it's greater than. So with that, we can reject our null and support for our research hypothesis. So we can reject our null hypothesis and say that there is a statistically significant difference. In this case, the current class of students mean score is statistically significantly greater than all students average in the course. It's directional, so we can put it back in the words of that. The key part to this question is the second part when we get into what if we changed the critical value to 5%. Now, if you think back, so we looked up the 1%. So if we change that and looked up the 5% here, we'd be looking up a value that's actually, in terms of critical value, less than what we already have. So if we already know that 3.49, our obtained value here, is greater than our critical value, by reducing our probability, or I guess increasing it, well, depending on how you want to look at it, increasing the chance of type 1 error, there we go, from 99 to 95. So there's 5% chance of what we conclude being incorrect. We still have the same conclusion. So if we, instead here, we would look for a value as close to 0.950. So the 5% still in this side over here. If I come back to our Z table and find as close to 0.95 as we can find, we get to 1.65. So for this one, it would be a critical value of 1.65, which we know our obtained value is already greater than. So we're fine there. So it would be further down here in terms of 1.65. So we're confident even at the 95% level, but even the 99% level, that there is a significant difference in the mean score between our current class and all students, be it we know the directionality, so it is greater than that. So don't be shocked if you see a question on the exam that gives you two different probabilities, and as you look it up, you might find different findings. If you went from 95 to 99, it could be the same, and that's where, from a conclusion standpoint, that I'm asking you to think about and put it back in the terms and understand kind of the information in front of you. So with that, if there's questions, feel free to reach out, but we'll move on to t-test coming up. So take care. Bye. Of course, I gotta close out of everything again to stop.